Hello everybody, GiveMan Math back here with another video. Today I will be analyzing the graphs of tangent, cotangent, secant and cosecant. Let's explore these graphs together. Alright, let's start with the first one. Tangent. Tangent kind of looks like a cubic function. It has three distinct points, and the first ones we have the 0, and then we have the pi over 4 and 1, and then we have the inverse of that, which is negative pi over 4 and negative 1. Alright, let's start by looking at its key features. The period is by pi, so it starts at the 0 and then it goes up by pi from an asymptote of pi over 2. So pi over 2 plus pi. So each pi over 2 is a new asymptote. Not each pi over 2, but each pi from pi over 2 is a new asymptote. Then we have the tangent. The tangent is sine over cosine. So we know that it is also, opposite over adjacent, all of that. Alright, so in our next instance, we have cotangent, which is different from tangent because it's the inverse of it. Instead of sine over cosine, it's cosine over sine, or adjacent over opposite, whichever one you know. So this asymptote starts at 0, so the asymptote is going through 0. Therefore, it starts at pi over 2, so it goes 1 pi over. So the period is pi. Secant. Secant starts at pi over 2 asymptote. Secant is 1 over cosine. Period is 2. Every 2 pi's it ends. Sorry. So here at 2 pi it ends. This ends at pi. This ends at pi. And so on. Alright, let's see. So, there's a practice that I'd like to do right now. Let's start on this practice. Alright, let's go to a random one. Okay, this one is going up by, first we need to acknowledge that it is starting at pi over 2, which means that it has an asymptote at 0. Now what that means is that this is a cosecant graph, because cosecants are always starting asymptote at 0, so C as C. Cosecant, asym, 0. This seems to have a midline at 1. Mid 1. There's an invisible midline that is here because we know that it has an amplitude of 1 above this midline, which is 2. This is where the points are. That's why I know that the midline is 1. Midline is 1. Asymptote is 0. Wait. Yeah, asymptote is 0. Alright, let's check our answer here. So I said cosecant midline of 1. This is B. Wait, 1 not B, no G. Alright, let's do G. G. Alright, let's see. This looks to be a cotangent graph because there's an asymptote at 0. Let's check. Indeed, I was right. Since there is an asymptote at 0, it is a cotangent. Let's go back to the question. Now let's correctly identify this with its correct answer. We see that it has a clear midline of 0, as it's written here. Alright. Let's see which one matches. This is cotangent. This is also tangent because it has an asymptote of pi over 2. And this is cotangent. And this is... I think this is a negative C. This is a negative cosecant. That's a negative cosecant. So D is a negative cosecant. D is a negative cosecant. What's H cotangent? I said H is a cotangent, and it starts, yeah, the midline seems to start at -1. There we go, I found it. Alright, this is H. So midline cotangent H. Alright, let's see. Alright, we clearly have, no, wait, this is negative cosecant. Alright, we clearly have a secant on our hands. This is a two amplitude secant. No, it is not. Wait, it is going. No, it's not. No, there's a midline at -1 here, so we know that this is A. All right, let's look at our 2 secant. This seems to be our 2 secant because it has an amplitude of 2. See, 1, 2. There's an amplitude of 2 between the midline. You count 1, 2 from the midline, which is 0, and you know it is a 2 amplitude cosecant, which is F. Sorry, this is the secant. Sorry, my bad. Secant. Negative also. Wait, not negative. Not negative, my bad. Alright. Let's look at the other ones. We have a tangent here. This tangent seems to be a negative. Let's check how tangents look. That's a cotangent, that's a tangent, that's a normal tangent. B is a normal tangent. So B seems to be here, 1/2 midline, which is, our midline is here because this point is also intersecting it. These points are also intersecting it. So we know that our midline is 1. So it's a midline 1 tangent. Alright, let's look at this inverse tangent over here. So we have an inverse, this is an inverse tangent. This is an inverse tangent at E. With, does it have a midline? Does it have an amplitude of 2? Yes, it does. It has an amplitude of 2. It has an amplitude of 2 here, 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 here. This is our midline of 1. Oh, sorry, 0. So now we know that E is a negative, so inverse amplitude 2 tangent. Alright, let's see our next one and our last one, which is a cotangent. Now this cotangent is, where is it? This is supposed to be C, because, well, you already know that cotangents have an asymptote at 0. So 0 plus pi goes to another pi. We have a pi here, and we go to another pi, and so on and so forth. 2 pi, negative 2 pi, 2 pi. That's why we know this amplitude of 3/2, let's see, 3/2 should be here. This is our amplitude. This is our amplitude right here. That's where it is. That's our amplitude, 3/2. Cotangent. So it is C. There we go. I hope this explained a lot about how you see functions. Secant has to have asymptotes at pi, negative pi, oh sorry, not pi, negative pi, but pi/2 and negative pi/2. You got the cosecants, which have not amplitudes, but the asymptotes at 0, and for every pi. And then you have the secants that have also that asymptotes at pi/2 and every other pi in front of it. So 3 pi/2, negative 3 pi/2, and then we have the tangents, which are asymptotes at pi/2, and then so on. And then we have the cosecants, which have an asymptote at 0, and then we have the cotangents, which have an asymptote at 0 as well. So I hope this helped, and stay hungry. Caveman Matt out. Take care, brothers.